The universe is a pretty big place, and it's expanding even faster than scientists originally thought. And countless mind-blowing phenomena happen there every day, whether or not they make it into the headline news. NASA has been around since 1958, and since then, astronauts have landed on the moon, parked a robot-controlled rover on Mars, and discovered thousands of exoplanets. The quest to find and investigate life beyond Earth has reached a tipping point. Humans have been wondering whether we are alone in the universe since antiquity. But what are 5 space discoveries of 2020 that could mean life beyond Earth? Let's see. Number 5. Potential signs of life on Venus. The announcement in September took the world by storm. Researchers using 2 radio telescopes found signals that the clouds of Venus were harboring phosphine, a toxic compound that on Earth is only made in significant quantities by microbes and chemists. The unexpectedly high levels detected on Venus could point to a floating microbial biosphere. The researchers suggested, now in the planet's atmosphere, the compound of phosphine and hydrogen is a potential marker of life. After the news, several studies followed questioning the observations and conclusions. Now, the same team has reanalyzed part of its data, citing a processing error in the original data set. The researchers confirm the phosphine signal, but say that it's fainter than before. The reanalysis, based on radio telescope observations at the ALMA in Chile, concludes that average phosphine levels across Venus are about 1 part per billion, approximately 1/7 of the earlier estimate. Unlike in their original report, the scientists now describe their discovery of phosphine on Venus as tentative. In one critique of the original study, researchers suggested that the signal reported as phosphine might really be coming from sulfur dioxide, a gas that is common in Venus's clouds but is not produced by life there. As we said, the reanalysis found that phosphine concentrations in Venus's atmosphere occasionally peak at 5 parts per billion. That means levels of the gas might wax and wane over time at different places on the planet, a situation similar to methane spikes appearing on Mars. According to the other study, which dug through decades-old data from NASA's 1978 Pioneer Venus mission, says that the spacecraft dropped a probe that measures the chemistry of clouds in the planet's atmosphere as it fell. It detected a phosphorus signal that could be attributed to phosphine or another phosphorus compound. But they believe the simplest gas that fits the data is phosphine. But where the phosphine comes from remains a mystery. Even at the 1 part per billion level, there is too much of it to be explained by volcanic eruptions at the planet's surface or by lightning strikes in the atmosphere. Phosphorus-based compounds might be produced by geological processes and then transform into other chemicals such as phosphine as they rise into the cloud. Researchers are still investigating many other aspects of Venus, says David Grinspoon, an astrobiologist at the Planetary Science Institute that is based in Washington, D.C. There are 1,001 reasons to go back to Venus, and if the phosphine goes away through further observations and analysis, there will still be 1,000 reasons to go. Number 4. Super habitable planets. Earth is the only planet we know of so far to host life, but it may not be the best place for life when compared with super habitable planets, according to a new study. And as scientists search for other planets outside of our solar system called exoplanets that could host life, planets much like Earth may not be the best answer. The lead study author and professor for astrobiology and planetary habitability at Washington State University, Dirk Schultz-McCuck, said that they are so focused on finding a mirror image of Earth that they may overlook a planet that is even more well-suited for life. In the new study, he and his co-authors identified 24 exoplanets and exoplanet candidates. They are all more than 100 light years away that could be contenders for super habitable planets with conditions more suitable for life than Earth. Those candidates and planets have not been positively confirmed that life exists on these planets. Instead, it means that these planets could have conditions that are conducive to life. Now, we caution that while we search for super habitable planets, that doesn't mean that they necessarily contain life or even complex life. A planet can be habitable or super habitable but uninhabited. This has to do with the natural history of the planet. There could have been a calamity like a nearby supernova explosion. Schultz-McCook identifies a super habitable planet as any planet that has more biomass and biodiversity than our current Earth. Essentially, it would be slightly older, bigger, warmer, and wetter than Earth, he said. One factor of super habitability may actually be the type of star the planets orbit. The researchers identify a K-dwarf star as the most ideal in the study. These stars have a longer lifespan than our Sun, so life could potentially persist and thrive on planets planets in orbit around them. K-dwarf stars are cooler, less massive, and even less luminous than our Sun, but they can persist for 20 billion to 70 billion years. Planets orbiting these stars would be older and allow time for life to reach the complexity that we have on Earth. Other criteria was used to determine superhabitability out of the 4,500 known exoplanets. The planets were likely terrestrial or rocky like Earth and orbiting in the habitable zone of their star, meaning the distance from the star where liquid water could stably remain on the surface of the exoplanet. Number 3. Kepler 1649c. If the name Kepler 1649c is not very easy to understand what it is, we can easily explain that it's the name of the most similar planet to Earth ever found in terms of both size and temperature. A team of transatlantic scientists using reanalyzed data from NASA's Kepler Space Telescope has discovered this exoplanet orbiting in its star habitable zone, the area around a star where a rocky planet could support liquid water. While the exoplanet does orbit with its star habitable zone, due to a lack of information on the exoplanet's atmosphere, it is unclear if Kepler 1649c can sustain liquid water on its surface. As of 2020, no solar flare-ups have yet been observed from the host star. Nonetheless, scientists believe that such stars are prone to frequent solar flare activity and that such flares may have stripped the exoplanet's atmosphere and hindered the prospect of life. Number 2. Rusty Moon. The moon is turning ever so slightly red, and it's likely Earth's fault. Our planet's atmosphere may be causing the moon to rust, new research finds. Rust, also known as iron oxide, is a reddish compound that forms when the iron is exposed to water and oxygen. Rust is the result of a common chemical reaction for nails, gates, the Grand Canyon's red rocks, and even Mars. According to a statement from NASA's Jet Propulsion Laboratory, the red planet is nicknamed after its reddish hue that comes from the rust it acquired long ago, when iron on its surface combined with O2 and H2O. Chandrayaan-1 was India's first lunar mission, which ceased operating in 2009 and was a highly successful undertaking that discovered water ice in the permanently shadowed craters on the lunar poles. The discovery proved a long-held theory about water ice and its relationship to the moon, but new research using those findings returned a surprise: rust far from those polar water deposits. So, as it's totally clear now, rust forms when the iron is exposed to oxygen and water, right? But NASA claims that the moon is not supposed to have liquid water, so how can it be rusting? It turns out Earth is to blame, with a little help from the sun. The solar wind routinely bombards the moon with hydrogen, which actually makes it harder for hematite to form because hydrogen adds electrons to the material it interacts with. Hematite needs the opposite, an oxidizer to remove electrons. Dr. Vivian Sun, planetary scientist and systems engineer in the science planning group at JPL, said, "In the end, the spectra were convincingly hematite bearing, and there needed to be an explanation for why it's on the moon." Number 1. Radio signals. Mysterious radio signals from outer space have been received in 2020. Actually, these signals were recorded before this time, but they have proved that they are repeated after a certain period of time. It has been a mystery then as to what astrophysical objects could produce such brief though brilliant radio flares. It appears that the observed radio pulses were produced by a magnetar, a type of neutron star with a hugely powerful magnetic field. Physicists have hypothesized that magnetars might produce fast radio bursts. This is the first time scientists have direct observational proof that magnetars are indeed sources of fast radio bursts. "This is the most luminous radio burst ever detected in our galaxy," said Danielle Mashili, an astrophysicist at McGill University in Montreal, who works on the Canadian Hydrogen Intensity Mapping Experiment, or CHIME telescope. A major question that remains is how magnetars unleash such intense blasts of radiation. One idea is that these magnetars are distorted by starquakes that tear open their surfaces and release vast blasts of energy. Another is that powerful flares from magnetars collide with particles in space, producing intense shock waves and magnetic fields that whip electrons around, releasing bursts of radio waves in the process. So does it mean that it could be a fact that there is life beyond Earth? What do you think about these discoveries? What about aliens? Do you believe in their existence? Let us know in the comments down below. Make sure you subscribe to our channel and turn on your post notifications so you never miss a video from us. If you like this video, don't forget to give it a thumbs up. See you in the next video, and thank you for watching.